as we know that our earth is not a perfect sphere. So this is the elliptical path our earth revolves in. This is an elliptical path our earth revolves. And this is the sun. Take it in red color. And this is the sun, and let it be blue for the earth. This is this, and this is our sun. So, but it is saying that our earth, this is the distance, this and the distance between the sun and the earth so this is the elliptical path in which the earth revolves around the sun. So the distance, the maximum distance between the sun and earth is known as the aphelion, and the distance between the sun where it is the shortest, it is known as the perihelion. It is approximate 147 million kilometers, and it is about 152 million kilo. So in this we have studied if we see at the angle of the inclination, when the sun rays are directly fall on the earth's surface, that is the perpendicularly, if this sun rays will fall on the earth at the angle of the 90 degree, that is perpendicular, and in case of the poles, the incoming solar radiations will form a slanting line, that is an angle of inclination is less than the angle of inclination at the equator. So at equator we have the 90 degree angle, and in case of the poles we have the angle that is less than 90 degree. In poles we have the angle, the angle is less than 90 degree. So if the sun rays directly fall on the equator, so it will get absorbed more, and in case of the poles, since this is the structure and this is the incoming solar radiation, so the area get heated is that much area is heated from the one single insolation, and in case of the equator this is falling the straightly down, so this will area get heated. So the area covered in the slanting rays is more, and in case of the equator the area covered from the incoming solar radiation is less. So the angle of the inclination, it maximum, that is the 90 degree at the equator, so it will be the area covered by the incoming solar radiation is less at the equator and more on the poles. So the thickness at the poles will be high and the thickness at the equator will be less. And during the duration of the sunshine, during the day we will receive the more sun rays, and at night we will receive the less sun rays. So in case of the summer we will receive more sun rays, and in case of the winter we will receive the less sun rays, that is the insolation. So but it concludes that summer solstice will have more incoming solar radiations than the winter solstice. Now the second affecting is because of the transparency of the atmosphere. So first one is the transparency of atmosphere. How the transparency of the atmosphere affect the distribution of the insolation is when there is more clouds. What they will do? Heat will be less. Why? Because the ridges, so the heat is less because of the ridges on the earth's surface is less. As the transparency will decrease, what it means is heat reaches on earth's surface will also decreasing because of the presence of cloud, but clouds it will absorb the incoming solar radiations. Let's understand this topic. This is our earth and this is sun. Now we have the incoming solar radiations. These are the incoming solar radiations. So in this case, the temperature at the equator will be high and the pressure will be low, that is the low pressure will create at the equator. And in case of the poles, the incoming solar radiations, that is slanting at the poles, it will there the insulation is less because the area covered from the 1 unit of the insulation is more, so the insulation is less. It will create temperature, so the temperature this at will be low, creating the high pressure. So the high pressure will be high since temperature and pressure are inversely proportional. At the temperature will pressure will be high. So and we know that the movement of the air is from the high pressure to the low pressure. We will do in the pressures in the next chapter. If there is a low pressure, there the air will be rising. So the air will start rising from here, and at since there is the high pressure, so air will absorb there. And as compared to these poles, there is an low pressure. As compared to the poles, pressure will be low, and as compared to pole, there is temperature will be high in comparison with the poles. And at the at approximate 30 degree, there is pressure will be high as compared to the equator, and as compared to the equatorial pressure will be high and temperature will be low. So there is high pressure zone and this is low pressure zone. So now this is the air is rising, and the the horizontal movement of the air is from high pressure to the low pressure. So this air will subject here and this will subject here, and this will rise at the equator, and in the pole it is sinking air, and at the 60 degree, and this is 30 degree. At the 30 degree we have low pressure. It will start rising air, and at 30 degree we are high pressure, so air will subtract here, shrink here. So now what will it do? Since it is a rising air, so it will form the clouds. It will form the clouds. Clouds will form here at the equator, and at the 60 degree also this is an rising air, so it will form the clouds. Clouds will form here. So what we have concluded, so since there are formation of the clouds, so there is more rainfall, and since at the 30 degree we have the sinking air, so no cloud form. At the poles least cloud will form. So here what we have concluded, and the formation of the cloud will, the incoming solar radiations will get radiated back. This will radiated back. So what we have studied here is at poles there are the least cloud form. Sun rays will slanting. So transparency will be high, since the formation of the cloud are less. At 60 degree we have transparency will be less. Why? Because of clouds. Insolation is very low, almost no insolation. At 30 degree transparency is high, no clouds, and so insolation will be high. So the insolation at the 30 degree will be high. At now at equator what we have, sorry, at 30 degree it is sinking air, na? At insolation, so the insolation will be high, transparency will be less, because of clouds. So this is the concept of transparency of atmosphere. Next factor affecting is the topography. Now the question is how topography affect the distribution of the insolation. In case of the high altitude, sun rays will reach first, and in case of poles it will take more distance to travel. If we take more distance to travel, so the insolation reaching on the poles will be low, and in case of equator distance is very less as compared to the poles. So what will it do? Since the distance is very less, so the insolation will be high. This is the how topography affect the incoming solar radiations. So there are mountains, then there is the plateaus, and there is the plain areas. When the incoming solar radiations are coming, then these are the first to receive the incoming solar radiation. So the solar radiation received at the plateaus, these are the mountains, these are the plateaus, this is the plain. And the distance traveled by the incoming solar radiation at the plains is much more, and in case of mountains it will be the less distance. So the amount of the insolation, so the insolation will be less here because the more distances it will take to travel, and the insolation at the high altitudes will be more since they were the first one to experience the insolation. So this is how topography affect the distribution of the incoming solar radiations. And there is the one effect also, that is the effect of slope. So this is the mountains, the plateaus, so when the incoming solar radiation comes, we will have experience at the top will be more as compared to the, so these are the incoming solar radiations. So in this case the solar radiations will be more, and in these areas insolation will be less, slanting lines. This is the concept of the insolation. That is, these are the factors how this is affected from the incoming solar radiations. Having different temperature comes together in contact with each other. So the temperature of higher body get transferred to the temperature of having to lower body, and resulting in both the bodies achieves same temperature. So what an conduction is? When two objects of varying temperatures come in contact, heat energy flows from warmer object to the cooler ones. So this process of the transferring of the heat is the conduction. So in conduction what is happening? Transfer of heat. Just like दूध उबाल के ठंडे पानी में रखना, so the ठंडा पानी will get warmer and the warmer will get cold until unless having the equal temperature. So the flow continues till the temperature of the both object reaches to the equal, or either the contact is broken. So the conduction in the atmosphere occurs at the zone of the contact between the atmosphere and the earth surface by the terrestrial radiations. Next we have the convection. So what convection is? Transfer of heat. How this will transfer of heat? By the movement of mass. From one place to another, like convection current. So what an convection is? Convection is the vertical rise, that is the vertical movement of air. Of convection is the transfer of the heat energy from one part of a liquid gas or a liquid or gas. Convection is always in liquid or gas by the movement of the particles themselves. As the lower part of the mass of the liquid is heated, molecules warm and then vibrate. Then the vibration between them is increasing, causing the collision that produce motion in the neighboring molecules. Gradually, it expands and reduces its density and rise to carry the heat. Example: the upward moving of the air is said to be rise in, as in the convection currents. Thus, the heat transfer of the heat from warmer to the cooler materials in this manner. Next we have advection. So that advection is the horizontal transfer. Horizontal movement of air. Is known as advection. So the transfer of the heat through the horizontal movement of air. Example: land breeze and sea breeze. So the transfer of the heat by the horizontal movement of the air is known as the advection. Mostly the atmospheric wind that blows over a region take the characteristics of the region with them. The temperature of a place rises if it lies on the part of the warmer winds. The temperature will dip if the place lies on the path of the wind blowing from the cold region. So in case of summers, this will have. So how this land breeze and the sea breeze are formed? During the daytime, we know that the specific heat of water is more. That is, specific heat of water is more. That is, it will take more time to cool and more time to warm. So during the daytime, what we have is earth, the land surface will get heated first. So this is the land and this is the water. During that daytime, land will be get heated first, so it will create temperature here will be high as compared to the water sea surface. There is temperature is high, so it will there pressure will be low pressure, and here we will have high pressure. So wind always move from high pressure to low pressure. Horizontal movement is always from high pressure to low pressure. So now in this case, what will wind do? Will start from this to this, and this to this, this to this, and this to this. Sorry. Wind will be from high pressure to low pressure. This is the phenomena of and at the night time, water, and this is land surface. At the night time, water will be more heat since it will take more time to cool, so temperature will be high here, so leading the pressure will be low here. And on the land, temperature will be land will get cooled first, so temperature will be less as compared to the water, leading high pressure here. So now the wind will move from high pressure to low pressure. So this is the movement of the wind. So the sea starts developing short wave before noon. It generally reaches at the greatest intensity during the midday of the late afternoon. At the night, the situation gets reversed. The land and the surrounding area cool more quickly than the nearby water. Thus, the land has the high pressure at the night time, and the sea surface having the less pressure as compared to the land area. So the wind will blow from land to the seawards. So this is known as the land breeze. Will form at the night time, and this is sea breeze. This will be formed at the daytime. So the pressure gradient is developed and carries the air will from high pressure to the low pressure, that is from sea breeze, that is sea from sea to land, and in the land breeze the movement of the wind is from land to sea. This is the formation of the land breeze and the sea breeze. Next we have the conduction done, convection होगा, condensation. So what an condensation is? Water vapor to water. So the conversion of water vapor to the water. How? Release heat, that is the latent heat of vaporization. So the conversion of the water vapor from water vapor to the water is known as condensation. Done. Heating and cooling of the atmosphere, we have maximum temperature per day minus minimum temperature per day is known as the Diurnal range. Now if we look upon the maximum temperature, have to be at 12 noon, because of the sun rays will fall directly on the tropic of the equator and in the mid. But in actually, but at what time we will feel it? At 2 to 4 p.m. we will feel the maximum temperature, and minimum temperature will be at 12 morning, but we will feel at 2 to 4 a.m. Now the question is, why is there is a lag? So because of the earth receive maximum solar radiation at the 12 noon, get trapped on the earth surface, but it will take more time in the re-emission, and it get trapped in the carbon dioxide and the gases. So the lag is behind that the re-emission will take time, that is when the earth get trapped in the, so this is the time when the insolation will get trapped in the earth, and this is the time when the earth receive the insolation, and this is the time when the earth have to release the terrestrial radiation back to the atmosphere. So instead of this, we will feel at 2 to 4 p.m. the maximum temperature as the maximum insolation coming from the sun, and it will radiate back to the atmosphere at 2 to the 4 a.m. because of the when the earth receives the maximum solar radiation, and it get trapped in the earth surface, and it will take time in going to the atmosphere back when they are radiated back to the earth. So the main source of the heat of the earth surface is sun. That is, so this is the sun. Incoming solar radiations, short wave, incoming from the sun, and this is our earth. Now let's suppose 100 units are supplied from the sun. Let's consider the insolation received at the top of the atmosphere is the 100%. While passing through the atmosphere, some of the amount of the energy is reflected, scattered and absorbed. Only the remaining part reaches to the earth's surface. Roughly 35 units are reflected back to the space even before reaching the earth's surface. So approximate 35%, no? Out of which 27 are radiated back to the clouds. Now suppose there are the clouds. There are some aerosol particles also. When this radiation come to the cloud, they are radiated back from the clouds, that is the 27%. And in case of the aerosols, these are radiated back by the aerosols, that is the 6%. And reflecting by the ice field on the earth, that is the 2 units. So 2 units out of them are radiated back by the ice present on the earth. So this is a 35%. 35% is directly radiated back. So this is known as the albedo. The reflected amount of the radiation is known as the albedo. So this is the albedo of the earth. Now thus the 35% of the radiation neither heats the atmosphere nor the earth surface. So this 35% of the incoming solar radiation will nor heat the atmosphere neither the surface of the earth. So remaining 65% are get absorbed in different portions. How these are get absorbed? Absorbed by the atmosphere 14 units. So out of them 14% is absorbed from by the atmosphere, ions, ozons and vapors. Now ions, ozons, now we have the ions, water vapors, ozone layer. So they will collectively absorb 14%, are absorbed by them, and absorbed by the earth is the 51%. So the remaining 51% reaching to the earth are the 51%. So total 35% albedo radiated back directly, 14% is absorbed by ions, water vapor and ozone, and 51 is reaching to the earth, absorbed by the earth, that is the 100% total. Now earth absorbs 51%. Scattering takes place by the gaseous molecules at the night and the dust particles. This takes place in all the directions, some of it in the eastward and some in the towards the space. Overall, Earth receives the 51% of the unit of the incoming solar radiations, which radiated back in the form of the terrestrial radiation in the night time. During the daytime, it will get absorbed by the Earth, and these are will radiated back by Earth at night. Out of them, 17% will go space directly. In space directly, and 34% is absorbed by, sorry, it is first absorbed तो दिन में हो चुके ना, at night it will radiate. Is radiated to the atmosphere. And when they are radiated to the atmosphere, they are get absorbed by the aerosols, radiated and absorbed by the atmosphere because of the aerosols, water vapor, carbon dioxide, and the other greenhouse gases. So now how these 34% will be radiated. Out of these 34 radiations absorbed by the atmosphere, from the terrestrial radiation, how out of them 0.6 units will be absorbed directly and absorbed through the convection and the turbulence 9%. And absorbed through the latent heat of the condensation, that is the heat, latent heat is the energy released or the absorbed from a body. 9 and 19 होगा ना, and 19% is absorbed by latent heat. This is the 34% distribution. Total 34 done. Now the total units absorbed by the atmosphere, how many unit atmosphere will absorb is, so now if we look upon the diagram, 14 units of the insulation, so these are the 14 units is absorbed by atmosphere, and the 34 units of terrestrial radiations is also absorbed by the atmosphere. यहाँ पे 14%. So the total amount of the so the total unit absorbed by the atmosphere is, total units absorbed by atmosphere is 14% plus 34%, that is 48%. This is the total which is get absorbed by the atmosphere. Okay. Thus the total radiation returning from the earth and the atmosphere are these 48 units. 35% is the albedo of the earth. So now the 17% is radiated by the earth and 48% is by atmosphere. It total is 65%. So the 65% unit will be radiated back by the earth and the atmosphere, and since the 35% is already directly radiated back, so total incoming solar radiation we have incoming short solar radiations we have 100 units, and outgoing long wave terrestrial radiations we have 65% is by earth and atmosphere, and 35% is the albedo by earth and atmosphere. 35% is albedo, total is 100%. So now what we have concluded is the amount of the incoming short solar radiation is equal to the outgoing long terrestrial radiations. So what is this? Heat budget या फिर heat balance of earth is 0. Good. So the amount of the incoming and the outgoing radiation always maintain the balance of the heat on the earth's surface. So the maintaining of the heat balance will be 0. Done. Now budget is nothing but the balance between the follows, that is the balance between the incoming short wave solar radiations and the outgoing long wave terrestrial radiation. So during the day, and in case of the summers, incoming short solar radiations are more than the outgoing long terrestrial radiations, that is positive, and in night and in winter, incoming short solar radiations are less than the outgoing long terrestrial radiations, that is negative, and in case of the annual, what we have is incoming short solar radiation is equal to outgoing long wave terrestrial radiation. So this is the heat budget. Now the phenomena of the reflection from the 35% of the unit out of the 100 are known as the albedo or the reflectivity of the earth. So the reflectivity declines with the different surfaces of the earth. Albedo. If this is the earth and these are the incoming solar radiations making this, and at the poles we have the slanting rays due to the surface, incoming short solar radiations, incoming short solar radiations. So which one of them having the highest albedo? Slanting rays. Slanting rays having the higher albedo effect, because if the solar insolation is vertically keeping the earth surface constant, so the albedo will be low, it will get absorbed. If insolation is inclined keeping the earth surface constant, then the albedo will be the high. That's why the poles having the highest albedo, whereas the equatorial regions have the lowest albedo. So what we have concluded is, at the poles we have high albedo, and at equator we have low albedo. Done. And 48% is reflected by radiated back by the atmosphere, maintaining the net heat budget. Now this is the concept of the latitudinal heat balance. That is the how latitudes affect the degree of absorption. This is our earth. At the higher latitudes and at the lower latitudes we have the more absorption, and at the higher latitudes we have less absorption. Now the question is how it is. We have studied that the insolation is directly proportional to the angle of inclination. More the angle of the inclination, that is 90%, having the more insolation, and having the slanting rays have less insolation because they get distributed among the whole area. So now this is we have the equator. So since at the equator the angle of the insolation is maximum, so the insolation will be maximum here, and towards the poles the angle of insolation get reduced. So we have a structure like this, that is different in the different latitudes energy to the earth surface. Now how it is. We have poles, we have equator, and we have pole here, and here we have the around 40 degree. Now since at the equator the angle of inclination is more, so insolation will be high here, and towards the pole it get reduces, and so here we have the surplus insolation, and at the poles we have deficit. Insolation. Now if we connect them average, then this is the reason. So this is the reason, this is the deficit reason, and this reason is the surplus reason. At the poles we have 6 months day and night concept, 6 months 24 hours day and night, and at equator we have 6 month ratio, 12 days, 12 hours of days and 12 hours of night. And again at the poles we have 6 months ratio, having 24 hours day and 24 hours night annually. So this 40% is the limit line, that is where the incoming solar radiation and the outgoing, this is the terrestrial radiation and this is the incoming short wave solar radiations. So this is the 40 degree is the line limit where the incoming, यानी कि at the 40 degree the incoming short solar radiations are equal to outgoing long terrestrial radiations. So at the latitudes below the 40 degree, more solar radiation is received, then it is lost to the space by the earth, and the opposite is true for the lighter latitudes where more heat is lost than the received. Although the earth as a whole maintained a balance between the incoming and the outgoing radiation, but it is the ratio is not uniform all over the earth. So till here, what we have studied about the insolation and the outgoing terrestrial radiations, we can conclude insolation is same. Insolation is same throughout the year, and the observation of the insolation is different. Why? Because of tilt of earth. So we can conclude that insolation is constant and albedo is variable. Done. So we have done